Okay, so looking at one of your homework problems, it says the intensity of the illumination at any point from the light source is proportional to the square of the reciprocal of the distance between the point and the light source. Two lights, one having the intensity 10 times that of the other, are 7 meters apart. On the line between the two light sources, how far from the stronger light is the total illumination least? Okay, so you got two light sources in here. And it doesn't matter where we put them. I'm going to blow this up just to get myself some more bigger pens. So we got our two light sources in here. And we're given that this is 7 meters apart. And there's some point on this line in between them that is going to be how far from the stronger light, the total illumination the least. So let's say that's the point where the total illumination is the least from the stronger light post. So, and I'm calling them light posts, but they didn't say light post. Let's just assume they're light posts. So let's call that distance from the stronger one, let's call that X. And then let's go back and let's look at this and what they're telling us about these values. So this is X in here. So that means this distance actually from the lighter light intensity right in here, that's going to be 7 minus X, because we know that whole distance is 7. So 7 meters minus X is that length. So let's go back to that intensity and look at the equation for the intensity. It said it was a proportion, and so let's rewrite it. So the intensity of illumination from any point of a light source is proportional. So let's say that this is I sub 1. So this is proportional, so K times the reciprocal of the distance. So let's just say, hey, that is D is the distance between the point of the light. I forgot the square. To the square of the reciprocal. So this should be a D squared. Between the light source. The two light source, one is having an intensity of 10 times that of the other. So let's say I sub 1, that's the one that has less intensity. So I sub 2, the intensity for that, this would be 10 times this. So 10 times K all over that distance quantity squared. But let's talk about that distance again. We said that distance between the larger one, that one was that distance of X. So let's put an X in here, because that's that distance for that light post to that point. And so the distance for the littler one, that distance we said was 7 minus X. Quantity squared. So the total distance or the total intensity of the illumination of the light for both light posts is equal to the intensity of the one that has the least illumination plus the intensity of the one that has 10 times that illumination. And so we can rewrite our function as I is equal to K all over 7 minus X quantity squared plus 10K all over X quantity squared. Okay, so we're trying to minimize this. We're trying to find out what's the least illumination. And so we're trying to figure out what X is there, the least illumination, that point on that line in between the two. And so I know I'm going to have to take the derivative of this and figure out what my critical points are. And so in order to take the derivative of this, let's rewrite this. And so we can bring up our terms from our denominator and rewrite it with negative exponents. And so doing this right now, I would have, let's do it over here. I is equal to some constant K times 7 minus X raised to the negative 2 power plus 10K all times X raised to the negative 2 power. So now it's in the form that I can go in and take the derivative. So remember, K is just some coefficients, just some number in there. And so just treat it like that. So like if it was 2 in there. So we're just going to leave it alone. Let's take the derivative of 7 minus X raised to the negative 2 power. So taking the derivative of that, we have to use the chain rule. So bringing down our exponent down front of negative 2 times the inside, 7 minus X. And now we are subtracting 1 from our exponent. So negative 2 minus 1. So our new exponent is negative 3 times the derivative of the inside. And so the derivative of the inside, derivative of negative X is negative 1. So that's the derivative of that first piece. And so now let's take the derivative of the second piece, 10K times X to the negative 2. So that 10K is staying the same. So if we look at taking the derivative of X to the negative 2, we're bringing down our exponent in front, negative 2, X, and we're subtracting 1 from our exponent. So that's going to be a negative 3. So let's kind of clean this up a little bit. So we have in front of right here, we have negative 2 times negative 1 times K. So that's going to give us positive 2K, all raised to the 7 minus X to the negative 3rd power, minus, so I have a negative 2 times a 10K. So that's a negative 20K. X to the negative 3rd power. Okay, we need to find out when this is equal to 0. I would probably rewrite this as a single fraction. So, or not as, well, maybe we don't have to. Let's do this. So we have 2K. Let's just rewrite it so our exponents are positive. So we have 2K all over 7 minus X quantity cubed minus 20K all over X cubed. This is I prime. We want to know when is our derivative equal to 0. And so we want to know when is I prime equal to 0. So let's set our equation equal to 0. So we have 0 is equal to 2K all over 7 minus X quantity cubed minus 20K all over X quantity cubed. I know because this is an equation, I can clear my fractions by multiplying through by my denominator, my least common denominator of my fractions. So I notice that looking at this, my least common denominator is going to be 7 minus X quantity cubed all times X cubed. So whatever I do to one side, right, I got to do it to the other side of my equation. But anything times 0 is 0. So we have 0 is equal to, so distributing, our fractions are going away. The whole point was so that would happen. So the 7 minus x quantity cubed cancels for that first fraction, and we're left with 2k all times the x cubed. Minus 20k. The x cubes are going to cancel, and we're left with this 7 minus x quantity cubed. Okay, so how are we going to do this? Looks like we might need to expand like terms, get like terms together. You notice I can factor out a 2k from both of those. So that would give me left with a x cubed minus 10k all times 7 minus x quantity cubed. Let's divide both sides by 2k. If we divide both sides by 2k, we get 0 over 2k is 0. So we get 0 is equal to this x cubed minus 10k, 7 minus x quantity cubed. I really don't want to expand that 7 minus x out and multiply it by itself 3 times and combine like term. I notice in here that both of those terms have a cube to it. So let's isolate one of them. Maybe let's add 10k 7 minus x quantity cubed to both sides. And if we did that, we have 10k 7 minus x quantity cubed equals x cubed. Well, it's an equation, so let's take the cubed root of both sides to get rid of those cubes. That will make it much easier to find out what x has to be to set that equal to 0. So it's multiplication in between. So I can rewrite this out as the cubed root of the 10k times, well, the cubed root of 7 minus x quantity cubed is just 7 minus x, is equal to the cubed root of x cubed, which is x. Okay, a little more doable. Let's now distribute our cubed root of 10k to both terms. So we would have 7 cubed root of 10k minus the cubed root of 10k times x. X is outside, equals x. So we have 2 terms in here that we're left with x. It's linear, so let's get all the terms with x to one side. So let's add that cubed root of 10k times x to both sides. So if we do that, we get this 7 cubed root of 10k is equal to x plus the cubed root of 10k x. So let's factor out that x from both of those terms. So we have 7 cubed root of 10k is equal to x times that quantity, 1 plus the cubed root of 10k. Okay, so now we need to just divide both sides to get x by itself. And so we get x is equal to 7 cubed root of 10k all over this 1 plus the cubed root of 10k. Okay, so that is the x value, which would set that equal to 0. We need to see that that is actually a minimum. And so there's multiple ways that we can test to see that this is a minimum value. This is a critical value. So we could test values on the left and the right to see what we have. So when I pulled out that 2K over here, I shouldn't have a K in here anymore. Right, I pulled it out of the 20K. So I shouldn't have this K in here. Shouldn't have that K in there. So I'm just going to get rid of that K everywhere. That makes more sense to me. Now we can actually figure out what this value is. There we go. So now let's go in and figure out approximately what that is, and then let's test on each side. Okay, so X is approximately 4.78. We're going to test to show that that is the minimum value approximately. And so the values which set the denominator equal to 0 is when X is 0 and when X is 7. Doesn't make sense to be past any of those because we're talking about distance. We have 4.78, this X value in here. And we want to test on the left and the right just to see, is it positive or negative into the derivative? Are we increasing or decreasing? So if we look at our function, let's see, and we plug it in. So we have I prime is equal to 2K all over 7 minus X. So if we plug in, let's test a value, maybe X equals 1. So if we have 1 in here, we have 7 minus 1, which is 6, and then we have 6 cubed. Okay, so 6 cubed, let's just write it, minus 20K all over 1 cubed, which is 1. So again, we can factor out, maybe it would have been better if we did that 2K. And so if we do so, we have this 1 over 6 cubed minus 10 over 1. Well, negative 10 is bigger than 1 over 6 cubed. K is positive, I believe. And so this is going to be a negative number. This is less than 0. And so we are decreasing. If we choose some number, so let's say X equals bigger than 4.78. So let's say 5. If we plug this back into our derivative function, let's pull out that 2K again. And if we plug in 5, wherever we see an X, we get 7 minus 5. What that is 2. So 1 over 2 cubed minus, plugging it in here, 10, because we pulled out the 2K, and then we have 5 cubed. So this gives us 1/8 minus 10 over 125. So that would be 2 over 25. So 1/8 divided by, or not divided by, minus 2 over 25. That is a positive number. This is greater than 0, so it is increasing. So the minimum value, that illumination, that distance from the longer light source is approximately 4.78. Just shrink this so you guys can see everything, but I don't know if that's possible. I think it's as small as I can get it. Type as an integer or decimal rounded 2 decimal places. So we should have 4.78 meters as our answer. away from the stronger intensity light, which we called ISO2, is going to be where it has the least illumination.